Hello everyone, this is Sachin again, and today we are going to talk a very interesting topic called interface endpoint. Um, so what exactly is this interface endpoint is consider that you have an S3 bucket. By the way, all these AWS services, the services like S3, SNS, they belongs to a public zone of Amazon owned network. They are not exactly part of like any VPC or in a private zone that is still public, but in a Amazon public zone. So let's say if you have to access any S3 bucket, usually what happens, the traffic goes via internet. It passes through the public internet and then it accesses this S3 bucket. But sometimes there could be a possibility that the EC2 instance may not have a public connectivity, or maybe because of security reasons or regulatory reasons or whatever be the case, your EC2 instance may belong to a subnet which may not have a public connectivity, and it needs to access this S3 bucket. So there is a concept called private link, and there are two kinds of primarily endpoints called gateway endpoints and interface endpoints. Probably in gateway endpoint, we will talk in some other video, and we will focus primarily on interface endpoints. So basically, interface endpoint is like one of the two ways where an EC2 instance can get a a kind of a private connectivity to your S3 bucket without the traffic going into internet. So which typically means is this subnet, which is depicted in blue color. I will explain the architecture in details ASAP. But just for now, if an EC2 instance may belong to a subnet which may not have an internet connectivity, can still access to S3 bucket. And how this happens? Via private link, the service is injected into the subnet, and they are available as an ENI, as a elastic network interface. So basically, it's a private IP, one of the IP belonging to the CIDR range of this subnet P. So this EC2 instance can leverage or use this interface endpoint and can access this S3 bucket even if it doesn't have an internet connectivity. So this is in nutshell about interface endpoint, and because we are going to do it as a demo, I'm going to explain the whole architecture, how I have set it up for the demo. So let's get it started. So first of all, I'm in AP Southeast 1 region, which is in Singapore region. So in one region, I have primarily two VPC, VPC1 and VPC2. For now, you can forget about VPC2. There's another concept I will explain, or the feature of interface endpoint. Consider the phase 2 in the later part of the video. I'll talk about VPC2, but for now, let's focus on the VPC1. So VPC1, which has a CIDR 12100/16, depicted by this purple boundary. It has two availability zone, A and B. Availability zone A has one subnet shown in a green color here, and availability zone B has one subnet shown in a blue color here. The subnet A, the one in green, is the route table is associated with an internet gateway, which is associated with this VPC. So which means this becomes a public subnet, because now the internet gateway, uh, the route table here, they you know they route all the traffic which is not local to this VPC, goes via internet gateway, and that's how any EC2 instance deployed within subnet gets an internet connectivity, and that's why it is a public subnet. Now let's talk about blue subnet. Here, the route table is not associated with internet gateway, and hence there is no direct public internet connectivity. However, to access a public internet, there's another way, is basically we can deploy a net gateway um, into a public subnet, and the route table can point into this NAT gateway, and that's where all the communication which starts, or like let's say there's a database or this EC2 instance needs to get some patch, the traffic, or like the connectivity can be started uh, within this subnet itself. Nobody from outside can access it, and that's why it's possible because of this NAT gateway. So in short, if this EC2 instance needs an internet connectivity, it is not associated with internet gateway because I don't want it, uh, because just adding it into an internet gateway makes it this subnet as a public subnet. I don't want it. I still want it to private subnet, and this NAT gateway is associated with the public subnet, and the route table is configured um, all the traffic via this NAT gateway, and that's where it gets the internet connectivity. Perfect. So this is the whole setup. As an user, um, I will be SSHing into an EC2 instance of the public subnet, and from there I will go into the private subnet EC2 instance. And here we will create an interface endpoint and will access this S3 bucket without internet connectivity. So I will show how to, from this EC2 instance, how to access this S3 via, not exactly this, via this route where the traffic goes via NAT internet gateway to public internet and goes S3 and get the record. So this is route 1. This we will see that. However, even if this EC2 instance does not have any public internet connectivity, it can still use this ENI, and via a tunnel it will access the S3 bucket without internet connection. So all right, this is the whole setup. This is my phase 1 of the demo. Now, because in the phase 2, what I'm going to do here is deploy another EC2 instance in a subnet B, which is a private subnet. Here you can see there's no NAT, there's no internet gateway, totally secure, but we will enable a VPC pairing over here. And not only this EC2 instance where these ENIs are injected, however, via a VPC pairing, this EC2 instance can also, via this ENI, access this S3 bucket. And this is possible only in interface endpoint and not possible in gateway endpoint. So again, I am not going to cover gateway endpoint in this video. This is primarily focused on interface endpoint, but I just want to show one of the major difference between interface endpoint and gateway endpoint. And by the way, this is on top of it. It provides much more features than gateway endpoint, and one of them we have seen right now. This is a paid service, unlike gateway endpoint, which is a free service. So let's go to the demo. Perfect. So now here you can relate. There are 3 instances, and as you can see, VPC1 has a CIDR 12.1.0.0.16. VPC2 has a CIDR 12.2.0.0.16. There are 3 EC2 instances in public subnet A, private subnet B, and this is anyway in a different VPC. So these are the 2 instances named 1A and 1B. 1A belongs to the public subnet, 1B belongs to the private subnet now. And we'll see why they are public and private because of this internet gateway connectivity. We'll just have a look right away. So this is my instance 1, and if we go down, we can see the subnet is associated with my sub public 1A. I've given the name just to it's very clear that this is a public subnet. And if you see B, this is a private subnet. And what makes it a public and private subnet is the association of an internet gateway. So I go to 1A, which is in a public subnet. So I go down, I click this subnet ID, it opens a new window. Now in this subnet, I choose it again. I go to the route table, and it is associated with RT with IG. It stands for route table with internet gateway. So I'm going to click this route table. All right, and I will go to the routes. So here we can see for all internal VPC it resolves to local. However, for any traffic it goes to an internet gateway. IGW is an internet gateway. If you click on this, you can see that this is internet gateway associated with my VPC. All right. In fact, we can go to all VPCs, and let me specifically rename it VPC 1 just for clarity. Perfect. So, all right. So now we go back to EC2 again. We have seen 1A belongs to public subnet, and let's see same where belongs to 1B. So I clicked on 1B. I go to subnet, which says my sub private 1B. So seems to be a private subnet. Let's validate it. Click on it. It opens a new window. Let me close the other window so they should not distract. Okay, choose the same subnet. Again, go to the route tables. Now this time it's associated with a different route table. So now you see the diagram. Um, the route table in subnet B is different than route table in this subnet. So here it was route RT underscore with underscore IG, stands for route table with internet gateway. However, here it is with NAT. Anyways, so let's click on this route table. Now here what it says, if we go to the routes, that for all the VPC 12.1.0.0.16 it should resolve to local. However, for any traffic it should go to the NAT gateway. So this is not going to internet gateway. This route table is pointing to the NAT gateway, and this NAT gateway has to be into a public subnet. Then only it gets the internet connectivity. So let's click on this NAT, and we can see that NAT is into a public subnet. So basically this depicts a whole architecture, whatever you see in a pink line, except the network interface endpoint, which we will be going to implement right away in this demo. All right, so now once the setup is clear, what I'm going to do here is, let's close it, go back to EC2 dashboard, and I have to eventually SSH into this box. I have to go to this EC2 instance in a blue or private subnet. So I cannot go directly. I need to go to a public subnet, EC2 instance. So let's click 1A, get the public IP, and let's click say SSH and public IP. Don't worry about authentication because my image is baked in such a way that it trusts my laptop. But if you are doing demo at your laptop, you can properly use the identity or pen file or user credential or whatever way the operating system allows to access. Anyways, so now I'm inside this box, and you can see the private IP written over here, 12.1.0.40, and we can validate it is 12.1.0.40. Now from 1A I have to go to 1B, and I'm going to copy the private IP address, and I'm going to do the same thing, SSH this guy. Now I am inside 12.1.1.47. So 12.1 is we know that's the CIDR for VPC1. However, the third digit, whether it is 0, it is public, and whether if it is 1, it is private. That's how I have set it up. Anyways, so eventually I'm into this particular box, and let's first validate whether we have an internet connectivity over here. And when we say ping google.com, and I see the packets are coming over here, so basically, which means the internet connectivity is here. All right, so I'm going to access this S3 bucket, and how I'm going to do is use the AWS CLI, which will connect to this S3 bucket, but via internet. So I'm not going to a tunnel right away because I haven't set up the interface endpoint yet. But let's access this S3 bucket, and this time the access will be with this route. It goes to NAT via internet gateway, it gets internet connectivity, and goes to public internet and access S3, and we get the response. Let's quickly validate that. So now we have already validated internet connectivity. I'm gonna say AWS S3 LS, and I have many buckets, so I don't want to list all of them. I just say grep infra. Okay, so from all of my bucket, it gets information that I have a bucket called such infra tf state. So this is a usual way. If you have an internet connectivity um, um, in your EC2 instance, you can access S3 bucket, which is in the public zone of Amazon network. All right, now what I'm gonna do here is basically set up this white arrow which is like setting up an interface endpoint, which will inject a ENI over here, and it gets a private IP address, and then this EC2 instance can access this bucket in the same manner. So let's do that. So I go to VPC. So let's open my next tab, look for endpoint under virtual private cloud, click on this and say create endpoint. And I'm going to say is my EP stands for endpoint 001. Whatever names you want to give, just give AWS service. So except DynamoDB, all AWS services are listed over here. Historically, S3 was not available, but now S3 is also available over here. So what I'm going to do here in the filter, I'm going to put S3, and it gives me some options. I choose the one default one without any outpost or any global thing. So I'm going to select it up over here. Now, because it's an endpoint, you can create either an interface endpoint or a gateway endpoint. Now, in this tutorial, my focus is more on the interface endpoint, so I'm going to ignore the gateway endpoint and select the interface endpoint with a normal, this is string. I don't want to do the other one which says outpost, something like that. So choose this one. Now, what VPC I'm going to deploy it? Of course, I'm going to deploy into VPC 1, and the subnet I'm going to choose is VPC B, because I do not, you can option, if you have like multiple subnets, you can choose multiple subnets. However, in my case, at least for this demo, I have only one subnet in availability zone B, so I'm going to choose only one. But it is not highly available by design, and if you want to make it highly available, you must choose in your production environment multiple subnets, because I don't have it, and that's the reason I'm not choosing it. So this I'm going to choose VPC 1, which is CIDR 12.1.0.0.16. Choose it, and I'm going to choose subnet B and my private 1B. You guys have already seen that. I'm going to leave everything default, and I'm going to associate it with a security group. So this particular security group is it's a demo. I do not want to restrict it on the security group level, and that's why I'm attaching a security group which gives the full access. It doesn't restrict anything. It's quite obvious, like for your production environment, you're not going to do that. This is just a demo. So let's check it and create endpoint. Perfect. So this takes some time. It's into a pending state. Probably we can wait for some time. Let me do a couple of refresh. I'm going to pause this video for some time, and once this is available, I will resume it. All right, so now I refresh and see that it took approximately a minute or two, and now this is into an available state. And what we can see over here in the description, this is the service name we anyway created for S3, and that's what you can see over here. And it has given us some DNS names star dot, and there is some string starting with VPCE and ending with .com. So this is basically works upon a DNS. Internally, it resolves into a private IP, which belongs into this subnet CIDR range. We'll quickly see that. But right now, let's focus that it creates a couple of DNS names. One is like a generic one, and the all other are specific to your AZs. So in the second one, you see it contains your region and -1B, basically because it was in a AZ1B. If you have like multiple subnets into multiple AZs, you could have seen a little, like some more DNS names over here. Nevertheless, you can choose any one of them. So I'm gonna take the first one, and using this endpoint, so basically this internally resolves into a private IP, and you can use this to tunnel and go inside and access S3. And how you can do that, and I have opened the AWS documentation. I will be sharing this link in the video tutorial, but you can follow this link and you can see how you can access S3 bucket is by using this command. AWS S3, give a region name, whatever region you belongs to, endpoint URL, and the URL should be https://bucket dot, and then whatever you see in the red color is basically the DNS name, and you need to replace it what you have got. You should not just copy as is, and s3:// and put your bucket name. So I have already copied this command over here for my bucket. This you have already seen. AWS S3 we have done it in where we have access this S3 bucket via this route. It goes through NAT and Internet Gateway, public internet, and S3. But this time I'm gonna use the endpoint URL, and it does not take this route. It internally goes here. We will prove it, and we'll see why it doesn't go over here. But let's first access the bucket. So now here it's the same command, AWS S3. Give the reason I'm into AP Southeast 1. Endpoint URL https:// bucket dot, and this is something which you need to replace it with what you have got. It starts with VPCE and with .com, and I'm going to see the content for such infra tf state file bucket. So I'm just copying it, go here and paste and enter. All right, so you can see that I am able to access the content of this bucket. If we see, even if we issue the first command, now it goes via an internet route, and still we see the same content. Now the first question comes into our mind: how do we know that this goes into via internet and this is actually not using internet? So let's do some changes, and let's disconnect the connectivity, internet connectivity. So what I'm going to do here is, if I say ping google.com, so again I just want to remind you I am into this EC2 instance, which is inside this blue subnet, which is in a private zone. It's inside a private subnet. So but here I can access google.com. Why it is? Because the subnet route table allows or access this NAT gateway, and that's where this guy gets an internet connectivity, right? So what I'm going to do here is press Ctrl C, go back to Amazon console again, and here let's go to EC2. It's easy. So again, this is the EC2 instance. Let's trace the subnet ID. Okay, and let's go back to its route table. Okay, RT with NAT, and you can recall that this is the route. For everything it resolves to NAT, and that's where I'm able to ping google.com. So let's edit route and cut this internet connectivity and make save changes. Let's give it a couple of seconds, and I hope this should be reflecting by this time. I do up arrow and press enter. So this time ping google.com does not work, and it is expected because now there is no internet connectivity into this box. I say Control C, I cannot access internet. So let's see whether I am able to access my S3 buckets. Okay, and you see there's no response over here, and it'll be like timeout or something after some time. So which means I'm not able to access my S3 bucket. So this route is cut. There's no way via internet to reach it S3. Let's check whether I can access the same S3 bucket via this ENI, via this interface endpoint. So I'm going to say Control C. Let me clear my screen for now, and I'm going to say up arrow to find the command which I have used to access the content of this bucket. But remember, this time we don't have any internet connectivity. We are still able to list all the content of this bucket. So that shows the power of your interface endpoint. And it's not like just a security reason that, if your subnet does not have a internet connectivity, it can still access the S3 bucket. However, the charges are also not incurred, whatever the transfer or you upload the object. The transfer charges are not there if you're uploading any object using these endpoints. But bear in mind, this service is chargeable. All right, so this finishes the part one of this demo. I hope you have liked it, and if you like, please like this video as well. Now let's quickly go back to the second portion of it. Had this been a gateway endpoint the only way to access the S3 bucket was within this VPC. Because it's an interface endpoint, that is, it's not only limited to this VPC, however, from another VPC, as long as the connectivity is stabilized via VPC pairing or via a transit gateway, you can access the same S3 bucket. Even if ENI is injected into one VPC, you can leverage this, and from another VPC you can access this S3 bucket. So basically, in this case, the connectivity will be from this EC2 instance via VPC2 pairing. Via this ENI, it is going to access this S3 bucket. Right now what you have seen is basically this EC2 instance via this ENI accessing this S3. So now see this route. Okay, so the first thing we need to do is stabilizing the VPC pairing between these two VPC. By the way, I have another video on transit gateways and VPC pairing, and I have in-depth discussed, along with all the hands-on demo, how to connect to VPCs via VPC pairing, or I think using transit gateways. Do have a look, but whatever mean is, whether you use VPC pairing or transit gateway, the VPC connectivity should be there. So let's do that. So I'm going to, in VPC, there should be peering connection, and I should create a peering connection between these two VPC. My PC-001, so from my peering connection, select a VPC. So I'm going to select VPC 1, and we can see this is 12.1 CIDR, and another VPC is again in my account. I'm not going to choose another account. This is still in the same region. I'm not going to choose another region and select VPC 2. This means the 12.1 and 12.2 are going to be connected, and that's it. Create peering connection. So the when you create a peering connection, the another VPC has to accept it, and because they both belongs to me, I am going to accept the request. All right, so I have clicked accept request, and you can just quickly verify over here. VPC 1 is a requester, and acceptor is VPC 2. It says the requester CIDR, so just accept request. All right, so this creates a peering connection. But just by peering connection, if we think that the uh, the connectivity has been stabilized and this can access this, that's not true. I show it to you. So now here, what I'm going to do here is 12.1.1.47, which is like from this box, I'm going to SSH into this box, which is into 12.2 CIDR range. And let's go back to EC2 instance, and this instance belongs to this VPC here in 12.2. So 12.2.46.197. Let me SSH. Of course, this connectivity is not there because you need to configure your route tables, and you tell them that to reach 12.2, what connection you need to use, and there we need to give the peering connection. So let's do that. So again, I'm into 1B. I have to find out the subnet. It belongs to private 1B. Here you go, and it has a route table, and this route table, go inside the route table, routes, edit route. All right, so here I need to tell that to go to 12.2.0.0/16, you must use a peering connection. And peering connection is my PC001, which we have just created. Save changes. So now what we have done is stabilizing the connectivity from here to here. But for response to come back, we need to do the same thing on the other side. So let's do that. So again, I go back to my EC2 instance, find out this EC2 instance, which in my diagram belongs to here in 12.2 range, which you can validate over here, 12.2. Let's find out the subnet, and then its route table, and I need to go to routes and edit route. And again, the same thing here, but this time 12.1.0.0/16. So it tells to reach out 12.1 what connection you need to use, and I need to use pairing connection in this case, same pairing connection, save changes. Now two ways connection has been stabilized. This time you should be able to SSH it actually. All right, okay, this has a chmod 400. Okay, now I need to check the permission. All right, so from VPC 1, I'm able to go to VPC 2. Now I should be do the same thing from 2 to 1. So go to EC2, find out the IP address of 12, the first VPC 1 EC2 instance private subnet, and SSH this guy. Yes. So basically we can from VPC 2 to now I'm SSHing to VPC 1 EC2 instance. Perfect. So basically we can SSH to and fro between these two EC2 instances. So which means this VPC pairing connectivity is working. Now the last thing remaining is in this VPC access this S3 bucket using this ENI, which is not even here, but it is present in VPC 1. So I'm into a EC2 instance which belongs to VPC 2, basically private IP in the range of 12.2. So let me first go 12.2. Perfect. Let me clear the screen. Now I'm inside the VPC 2, basically into this EC2 instance. And let me access. So as you can see, we don't have any internet connectivity. There's nothing is stabilized over here. And if we access the content of this bucket using the same endpoint, press enter. Oh, okay. Unable. So here I haven't put the credentials yet. So let me put it. I already have copied the credentials. Of course, you need a credential to access the content beyond connectivity. So AWS S3, AWS configure. I need to give access key, secret key. By the time I share this video, I'm going to delete this access secret key. So it's safe to do that. Southeast 1, that's it. So let's now access the content of this bucket. Now we can see even we are in VPC 2, which has nothing to do with interface endpoint, which has been injected into VPC 1, but still as long as the connectivity is here, even from another VPC, we can access this ENIs and this S3 bucket. So I think that's quite powerful. And the last thing which I promised to show you, that this resolves into a private IP, and because this DNS has been created into this subnet which has CIDR range of 12.1 and I have created into 24, so it should be 12.1 0.0/24, something like that. So let's see. Yes, 12.1, oh sorry, 12.1 and 132. So basically this resolves into an IP address which must be definitely within the CIDR range of the subnet where this ENI has been created. So all right, that's pretty much from my side. I hope you guys have learned something new and very interesting. If that is true, please like this video and share with your friends. Thanks for watching.